So I'm Sheridan Few. I'm a lecturer in urban energy systems at the Sustainability Research Institute in the School of Earth and Environment at the University of Leeds. My background is initially more technical, so I did my PhD on the physics of solar cells, and I've modelled energy systems at a range of scales, from kind of microgrid level to national to global models of the energy system, to understand some of the systems changes, some of the technical changes we need to get to net zero. More recently, I've become more interested in the decision-making processes. So, I think even with the best technical approaches in the world, you still need decision makers to act upon those. So I've become more interested in the processes there and how to join together some of those more technical aspects with the decision making that we're doing across scales to deliver net zero. So there's a lot of great work going on in the Supergen project around some of the kind of systems challenges around reaching net zero, how we need to change the kind of technologies and how those can work together to deliver a zero carbon economy. We see our role in the project as more on the kind of structural changes that need to support those. So who's making the decisions, who's impacted, how do we go from having that kind of technical vision to actually delivering it? How does that look different across different scales, and where are there gaps to exploit there? And we're working closely with some local and regional authorities on this, speaking to the network operators, particularly working closely with the Yorkshire and Humber Climate Commission to understand the challenges in this particular area around networks. So there were three key areas of this work package. The first is around decision making under deep uncertainty. So there's a lot of different actors involved in the energy space, a lot of uncertainty, a lot to resolve about exactly what mix of supply and demand measures we have, and our networks need to be designed to accommodate those. So this is about how we best make decisions about our network that these different actors can agree on, while recognizing that we don't know everything about how the energy system is going to develop. The second is around participation in modelling. So who designs the models of our networks, what assumptions go into those, who has access to those models, and how can that be improved to make a more effective and a more just kind of plan for net zero. And the third component is around vulnerability. So who is energy poor at the moment? How can the transition to net zero support those people? How can they be included in these discussions? And how can we avoid adverse impacts of those transitions and avoid people being left behind? There are a range of strategies for how we get to net zero. Some of the strategic elements of those are clear. So it's clear that we're going to be using more offshore wind in this country, and that we'll have to upgrade transmission networks to accommodate that. It's clear that a lot of our heat and transport needs are going to be powered by electricity rather than by fossil fuels, and that's going to require some upgrading of local distribution networks that take electricity to individual households as well. But I think even though we've got some of these strategic elements worked out, exactly how that's implemented across local areas, there's still a lot to be decided on. And I think that's particularly important now because historically a lot of the country's success in decarbonisation has been in changing our electricity supply, so moving from coal to gas largely, and also in growing role of renewables, which has largely happened far away from people's homes, and hasn't really involved a great amount of change at a local level. But as we get to the next stage, as we make these changes to heat and transport, the local context is going to become much more important. So you need a much wider range of stakeholders and a greater understanding of place to deliver that, and to understand what the network needs across places. To give one example of an area where there's a lot still to be defined, so heat is an area that we know that we're going to need to change a lot. The UK The vast majority of domestic heating in the UK comes from natural gas at the moment, which is clearly a fossil fuel and emits carbon dioxide. One potential solution is air source heat pumps, which will be important in a lot of locations. These are kind of devices installed on an individual household that use electricity to pump heat from outside the home into the home. It's very efficient, but might not be suitable for some locations, and there might be opportunities to do things at a larger than individual home level that might be more cost effective in some cases. So another area is heat networks. So this is a system that directly produces heat in a more centralized facility. Might come from a waste to power plant, might come from an industrial facility, and that heat is used to heat water, which is then pumped around a number of houses to directly supply heat through a heat network in that way. This might be more effective in areas where you've got more closely clustered houses, potentially where there's not as much room for a heat pump on the outside of those houses. And there are also kind of intermediate scale solutions, so such as kind of street level geothermal, which uses the heat from the ground to kind of preheat some water, which you can then use with a heat pump to boost the temperature up, which might not require as much space in houses and might be more efficient. There's also potential role of larger geothermal attached to heat networks, and maybe in some locations that are particularly close to industry or particularly hard to reach with these other decarbonisation measures, there might be some small role for hydrogen. So we've got three kind of separate types of network we're talking about here. We've got an electricity network, which is going to have to deliver a lot more to power these heat pumps. We've got a heat network, which some cities have, but are likely to expand a lot in the future, particularly with the heat network zoning, which is going on at the moment in the UK. And a gas network, which maybe will need to change to hydrogen in some regions, and will probably has to play a declining role across the UK in general. So decisions about how we balance these different solutions, what makes sense in different locations. Some places will have some good geothermal resources, some places will have electricity networks capable of providing electricity for heat pumps, and some places will have different kind of socio-political contexts. People might be more inclined to go for different options in different places. So deciding all of this remains a challenge. Across these different locations, you'll have a range of different stakeholders. You'll have local governments, network operators, regional system planners, and of course individual households. And each of these are likely to have perspectives on which solutions make sense, both from a technical perspective, but also, so incorporating these aspects of what the existing networks are capable of, what geographical resources are present, but also from a socio-economic perspective. So, how we make sure that a particular area that has more vulnerable consumers isn't going to be left behind in a transition, where we should prioritise those energy users, for example, in insulation, or where it's kind of, how to avoid those communities being the guinea pigs for these solutions as well, where you've got more affluent places that might be able to afford to pay more for their heat, and where you have places that are less capable to do that. And I think it's really important that we make these decisions in a kind of structured way around a plan, because if you end up having individual households installing a heat pump, where you then later have a heat network, or where you have a kind of heat system for that entire street, then you've got a kind of wasted investment there. We strategically understand the technologies that are going to be important reaching net zero. There's a lot of work to be done in how to implement that in different places, and a lot to be gained by doing that in a kind of more coherent way across different places. So one of the things we're doing as part of this Supergen project is conducting interviews with local authorities, some combined authorities, so kind of local government representatives, network operators, and other stakeholders in the energy system to understand how we can better make some of these decisions at a local level. So one of the kind of primary process for doing this in England at the moment is the local area energy plan, which kind of the idea of that is to go from a strategic level of the sort of things we want to see to more of a street by street level. How much of what technology do we want to deploy in different places? At the moment, this is quite patchy across England. Some local authorities have done it, some have completed them, some are working on them, some haven't really had any engagement in that process yet. And we're trying to capture some early evidence of different local authorities at different stages in this in order to maybe inform local planning going forward. So this is kind of ongoing research, but some of the kind of emerging outcomes that we found interesting in a network context are around scale. So some of these are done by individual local authorities and some are done by a range of local authorities together. Where they've been done by a group of local authorities together, there can be opportunities to exploit things across resources across boundaries. So for example, you might have a more rural area that's able to supply more generation that's used in a more urban area that has less space but high levels of demand, or urban areas might be able to implement kind of EV charging infrastructure for commuters coming in from a rural location. So there's definite advantages of doing things at a larger scale, but there can also be issues around, so there can be some resistance at a local level of too much of a focus on kind of consistency. So, local authorities are the elected representative of their local areas, and in some ways are the best placed people to understand what the issues are and the approach that should be taken at that local level. So there's benefits and disbenefits of doing these things at different scales. If you plan at a larger scale, you're maybe able to take account of some complementarities across different regions. Maybe putting generation in some more rural areas that has space, maybe putting EV charging infrastructure in more urban areas where commuters from rural areas might come to charge their vehicles. But there's also some of these things have to be delivered at a local level, and understanding which things should be decided at a regional level, the benefits of kind of groups of local authorities coming together to develop their plans in a kind of consistent manner versus something that's kind of driven by the local authority, I think is one of the questions we're going to have to answer going forward. And also how that planning interacts with, for example, the heat network zoning process, which is currently defining areas that new builds will have to connect to heat networks across England, which is being implemented from a more central level, and regional energy system planners, which are kind of trying to join up some of those aspects at a subnational but still larger than local authority level. So I think given that networks have a key role in joining these places together, understanding some of those interactions, understanding the network impacts of making those decisions at different scales is a really important factor for this project. A model is a simplification of a real system, which we can use to ask questions about that system, which would be very hard to do in real life. So, for instance, what would it do to people's bills if we were to insulate houses on a particular street? Will the electricity networks in this area be able to cope with a higher level of heat pump installation? What would it cost to build a heat network here or decommission this section of network? And these models are often populated by a lot of data about local areas, and they can be used they can play a key role in how we plan for delivering net zero. These models can help us to answer questions like what technologies would be best placed where, what approach would make sense in which different place, but they can also often be quite opaque. So the model designer will have had to make certain assumptions about how they think the system looks, and those often aren't transparent. Local authorities often have access to kind of a subset of those assumptions, and they often won't have access to the model itself or be able to implement the full range of changes they might like to see or run new scenarios to ask new questions very easily. So one of the things we're interested in is how models are being used currently in planning for the future of energy networks, and how those can be made more participatory, how those can be opened up to be used, and the assumptions can be scrutinised by a wider range of parties. One of the areas we're interested in this project is vulnerability and the interactions between energy networks and vulnerability. So at the moment, many people are still really suffering from the cost of living crisis, and the cost of energy has obviously become a much more important factor for many people in society. So there's a lot of questions about what we do about that now that need answering, but we're also trying to do a bit of a forward look into how changes to energy networks might affect those groups. So there's a couple of ways we're thinking about this. One is in terms of people not being left behind, making sure that as you transition to a zero carbon energy system, those groups can feel the benefit of that. For example, insulation and lower bills, and shifting to new technologies, but at the same time avoiding these vulnerable groups being kind of guinea pigs for all of these changes. So, them not having to be the groups that everything is kind of tested on, and having involvement of vulnerable groups in how we make these plans. This is an area we're still kind of developing, but we've got some emerging issues. We know we're going to need to upgrade a lot of our electricity networks. How do you do that in a way that's equitable? How do we avoid vulnerable energy users overpaying for that? And also the networks that will play a declining role, like gas networks, we're expecting to have to decommission at least large parts of those. And you could end up with a situation, for example, if 90% of a street is shifted to electric heat pumps and you have 10%, maybe of the less affluent, the less able to make that switch, who are still relying on gas heating. How do you avoid those people overpaying for maintaining that network that's serving far less people now? So there's still some important questions about changes to networks, who pays, and how vulnerable energy users can maximise benefits and reduce the negative impacts in that transition. So as we reach this delivery stage of net zero, as we start to need to make changes to how we heat our homes, how we get around, local authorities play an increasing role, but it's also going to be something that we can't do by stealth. People are going to notice these changes happening, which makes the question of how we engage communities become increasingly important, and how communities can feed into these plans, and how we can get social license for plans to get to net zero. And I think it's fair to say that this is an evolving area. There's no one way of doing this. Many local authorities are engaging with certain community groups and housing associations, community energy groups in producing their local area energy plans, but there might also be later stages of consultation with the community and how to amend those, if those represent a future that communities want to see, how willing they are to make the changes that those entail. There are interesting mechanisms that we probably won't have the capacity for within this project, but things like citizens' assemblies, which can be used to have a kind of longer term engagement with citizens in a community to gather their perspectives on how to reach this target, kind of really get a shared ownership between kind of established actors and the broader citizens at large, shared ownership of this problem between these different groups and how we tackle it. So I think this is a big question, and net zero we know is getting increasingly polarized. So I think having a way of developing these plans at a community level is important, and because networks join all these different aspects together, because the way we plan energy has to be supported by the networks, I think you end up getting into some of these kind of thornier issues when you think about how we plan our networks for net zero. We recently published a tool called the UK Low Carbon Technology Database, and what this does is it first of all maps some characteristics of local networks across the UK, across urban and rural areas. It does this at quite a fine geographical resolution to about 700 households. Then we look at scenarios of future deployment of heat pumps and electric vehicles that come from the distribution system operators, and look at how the impacts that those levels of deployments of heat pumps and electric vehicles might have on local networks. So where networks might need upgrading, where that might cost more and where it might cost less, where might be the best places to put flexibility to avoid, so for example, where to put storage, or where it might be important to facilitate people reducing their electricity demand at peak times to make the best possible use of our existing networks and minimize where we have to upgrade them. And this is a tool that we're keen to continue to develop and keen to use with local authorities to support their planning going forward. For instance, implementing different scenarios of putting different technologies in different places, where you might have more heat pumps, where you might have heat networks, where you might have hydrogen in some areas potentially, and helping to support those local authorities to know where the networks are going to be capable of supporting those more electrically intensive technologies, and where it might be better to choose another option to get more of a handle on what to do in different areas. So as part of this second phase of the Supergen Energy Networks Hub, we're focusing on accelerating, scaling and impacting, so kind of going beyond understanding the changes we need to see to the energy networks to actually how we support the delivery of those across scales and in different places. And that's really a key aspect of what we're doing here. So we're working across different local areas to understand the processes they're taking to planning, how they're anticipating going from planning their energy systems and the energy networks to supporting them to actual delivery of those. And I think this kind of policy society in place area becomes that much more important as we get to that delivery phase, as we get to that accelerating, scaling, impacting phase, and think about how we can actually make these changes happen across scales to deliver that net zero target that we have to hit.